Hello dear student, welcome to the course Digital Electronics and Computer Organization by Department of Information Technology, Sanjeevani College of Engineering, Kopargaon. In this video, you will learn topic 1.1 number systems from the unit 1 combination logic circuit. In this video, you will learn the number systems, decimal number system, binary number system, hexadecimal number system, octal number system, and conversion of these number systems from one to another. Let us first discuss about the decimal number system. Decimal number system is the most popular number system used across the globe to represent numbers. For example, if we go to the grocery shop, then we ask the shopkeeper to give 5 kg of sugar. If we go to the milkman, we ask the milkman to give 2 liters of milk. That is, in our day-to-day life, we extensively use the numbers, and these numbers are represented in a number system which is the decimal number system. The characteristics of the decimal number system is such that it uses 10 different symbols to represent any number. So any given number can be represented by 10 different symbols. We know those symbols. These symbols are 0 to 9. This decimal number system is said to be base 10 or radix 10 number system because there are 10 different symbols in this number system. Every digit in the number system has the weightage of some power of 10. For example, the number 7825 can be expressed as 7 into 10 to the power 3, that is, the digit 7 has the weightage of 10 to the power 3. The digit 8 has the weightage of 10 to the power 2. The digit 2 has the weightage of 10 to the power 1, and the digit 5 has the weightage of 10 to the power 0. That is, every digit has the weightage of some power of 10. Even if we consider fractional decimal numbers, let us say 12.34, it can be expressed as 1 into 10 to the power 1, 2 into 10 to the power 0, plus 3 into 10 to the power minus 1. So 3, which comes after the decimal point, has the weightage of 10 to the power minus 1, whereas the digit 4 has the weightage of 10 to the power minus 2. So like this, every number in the decimal number system has got a weightage which is some power of 10. So this is the characteristics of the decimal number system that is most extensively used in our day-to-day life. There are other number systems also which can be used for representation of numbers. For example, there is a binary number system. This binary number system is extensively used by the digital devices and systems, for example, computers. So computer is one of the digital device, and it uses this binary number system. This binary number system has only two symbols, 0 and 1. So any number can be represented in the binary number system using these zeros and 1. So it is said to be base 2 or radix 2 number system. Every digit in the binary number system has a weightage of some power of 2. Like in the decimal number system, every digit has got the weightage of some power of 10. Every bit in the binary number system has got the weightage of some power of 2. For example, if we take a binary number 1011, it can be expressed as like this: 1 into 2 to the power 3. So the weightage of this particular 1 is 2 to the power 3. The weightage of this 0 is 2 to the power 2. The weightage of next one is 2 to the power 1. The weightage of the LSBB bit is 2 to the power 0. We can have fractional binary numbers also, like the fractional decimal numbers. For example, 11.01 is one of the fractional binary number, and it can be expressed as 1 into 2 to the power 1 plus 1 into 2 to the power 0 plus 0 into 2 to the power minus 1. So the 0 which is after the binary point, in the binary numbers this particular point is called binary point. Like in the decimal numbers, we call that particular point as a decimal point. In the binary numbers, the point is called the binary point. So that is the weightage of this 0, which is 2 to the power minus 1, whereas the weightage of this particular 1 is 2 to the power minus 2. So as you go towards the left from the binary point, the weightage of every binary bit increases, and it is some power of 2. Whereas if you go towards right from the binary point, then the weightage of each binary bit decreases, and it has some negative power of 2. So this is how is the characteristics of the binary number system, and as discussed, it is used by the digital systems. In addition to the binary number system, we can represent numbers in hexadecimal number system or octal number systems. The binary number system uses only two symbols to represent any numbers. Hence, the numbers represented in binary are usually very long numbers consisting of too many binary bits. To quickly convert and represent numbers in the number system with compact representation, hexadecimal or octal number systems are used. The hexadecimal number system has 16 symbols, 0 to 9 and A to F. So total 16 symbols are there, whereas the octal number system has got 8 symbols, 0 to 7. Numbers can be quickly converted from binary to hexadecimal or octal or vice versa. So in the next video we shall see this, how these numbers can be quickly converted.